It's a stormy night. The sky growls with distant thunder. Raindrops fall like tiny liquid arrows shimmering under the glow of streetlights. Now imagine walking through that storm, without an umbrella, and yet staying completely dry. Not because you're wearing a high-tech raincoat, but because you're protected by something that sounds like it belongs in a sci-fi blockbuster, a laser umbrella. Sounds crazy? Maybe. But before we write this off as pure fiction, let's pause. Because science has a strange habit of turning the absurd into the possible. And sometimes what sounds ridiculous is just a question we haven't answered yet. So let's investigate. Can we actually stop rain from hitting the ground using lasers? Is it technically feasible? What would it take, and why would we even try? To begin, we need to ask, what is an umbrella really? It doesn't stop the rain. It just intercepts it. It's a passive shield. But what if, instead of intercepting, we vaporized? A single raindrop seems harmless, almost poetic. But water, in its simplest form, carries astonishing energy potential. To vaporize 1 liter of water, you need around 2.6 million joules of energy. That's roughly equivalent to running a mid-size electric oven at full blast for 10 minutes. Now imagine a modest rainstorm, half an inch of rain per hour. Multiply that across just 1 square meter of surface area, and you've got a vertical river pouring from the sky. Crunch the numbers, and you'd need about 9 kilowatts of power per square meter to evaporate that rainfall in midair. That's nearly 10 times the energy Earth receives from the sun per square meter at high noon. In essence, a laser umbrella would require you to summon a personal sun just to stay dry. And that's only the beginning. Next comes the problem of precision. Because rain isn't slow, it falls fast, it moves chaotically, and there are millions of droplets. A single cubic centimeter of rain can contain thousands of individual drops. To stop them in their tracks, you'd need to track every one of them in real time, calculate its trajectory, and fire a focused laser beam at the exact moment. Sounds impossible? Well, kind of. We do have technologies today that track fast-moving objects, high-speed cameras used in sports, motion tracking systems in missile defense, even eye tracking for virtual reality. So in theory, it's not unimaginable to build a system that detects raindrops and targets them with millisecond precision. But practically, it would be like running a NASA-level mission every time you go outside during a drizzle. And the laser itself? It has to be not only precise but also fast and powerful enough to fully vaporize the droplet in flight. If it's too slow, the drop hits you. Too weak and it just splashes. Yes. Lasers don't always vaporize. Sometimes they explode the droplet. Literally. When a high-powered laser hits a water droplet, it often causes what's known as micro-explosive fragmentation. Instead of cleanly turning to vapor, the droplet shatters into a fine mist of even smaller droplets, creating a kind of miniature rain cloud around you. So not only are you still wet, you're now enveloped in a chaotic fog. Scientists have spent decades studying how to deliver laser energy in just the right way. Fast, focused, and at just the right intensity. Too little? Nothing happens. Too much? You've made the rain worse. The key isn't just power, it's balance. Let's suppose, just for a moment, that we solve all of this. Unlimited energy, perfect targeting, super smart sensors. You walk into a thunderstorm, and an invisible dome of laser beams vaporizes every drop before it hits you. You're dry, but the air around you is now filled with hot steam. You've created a mini sauna. More precisely, you've built yourself a personal autoclave, a sterilization chamber of boiling vapor. You're not drenched with water, but you might be sweating from the heat. Your skin is dry, but you're cooking from the inside out. So what if we ditch the precision and go for brute force? Just shoot laser beams in every direction. Blanket the air with invisible fire. Sounds bold, but here's the problem. Even in heavy rain, most of the air is still empty space. Raindrops are small and spaced apart. A randomly fired laser might travel hundreds of meters before hitting a single drop. It's like trying to shoot fish in an ocean. And worse, shooting high-powered lasers indiscriminately in public spaces. Not only dangerous, probably illegal. You'd be risking the safety of pedestrians, aircraft, animals, and maybe a few satellites. A laser umbrella could quickly become a laser hazard. So maybe the real question isn't, can we stop rain with lasers? Maybe it's, why would we want to? In a world where we're obsessed with control, this question becomes strangely profound, because we already have simple, cheap, elegant solutions to deal with rain. Umbrellas, raincoats, roofs. What draws us to this idea isn't practicality, it's symbolism. A laser umbrella represents more than protection. It's a metaphor for domination, for bending nature to our will, for using light itself as a shield against the heavens. It's the dream of turning science into sorcery. But maybe, just maybe, the beauty of rain is precisely that it can't be stopped. Maybe that's the point. Rain reminds us that we're still connected to a world we didn't create, a planet that breathes, weeps, and sings in water. Each droplet has already been an ocean, a cloud, a tear, a flood, and it will be again. The laser umbrella might be technically possible one day, but perhaps the future doesn't lie in vaporizing rain, but in learning how to walk with it. To accept that not every drop needs to be erased. Because in the end, maybe what defines us isn't the light we build, but the shadows we choose to honor. If this video made you stop and think, even for a second, about science, imagination, or just how weirdly beautiful the universe can be, then that's already a kind of success. Now I'm curious, would you use a laser umbrella if it actually existed? Tell me in the comments. And if you enjoy questions like this, where science meets wonder, then hit that subscribe button, give this video a like, and share it with someone who loves asking the impossible. Because the next question might be even stranger, and you won't want to miss it.